Hi, my name is Chimezie. I'm here to give a short presentation on Icebreaker application that I recreated using my professor's video. So before I proceed, before I go into the technical aspect of it, I would like to explain what the application is all about. So it's a simple app whereby a user generates a random question by clicking on a button and then responds to that question and clicks on the submit button. So the response and the user's details will be sent to a database which we use to store the state of the application persistently. So let me explain the technical aspect of it. So I built the application using Kotlin programming language and Firestore database. Firestore database is used to store the state, the variables of the application persistently. So so let me move on to explaining the procedure I followed in building the application. First, on Android Studio, I used Android Studio IDE as my tool where I wrote the code and tested it. Then while doing that, the first step I followed to you know create the app was I first of all created a project folder. So, and I also choose a template. After creating the folder, I chose a template for the application. The template is just like how the application is going to look like, and the template is a composable template, which is a new technology that enables the GUI, the graphical user interface of mobile application, Android applications to be developed easily. So when I created the project and chose the templates, the Android subsystem generated or created a bunch of folders with some files, some files that have default settings for my application. As you can see on the left hand side of my screen, I have a bunch of folders, but the most interesting folder is actually the application folder that bears this folder that bears the application name. Within it, we have the main activity file, the main screen file, and we have three files actually. So the main activity file is generated by default. So it represents the entry point of my application and the foundation upon which I have to build on to develop the application I desire. So the main screen and the question are user defined. I actually wrote these ones. I defined the main screen. The main screen represents, of course, the graphical user interface, the how I want the layout to look like, and the question represents our data, the signature of the data that my application is going to use. So in building this application, I followed a design pattern known as MVC. M stands for model, V stands for view, and C stands for controller. It's a very robust system of developing application that modularizes it. It splits it into, parts and makes the development or building process very easy. So each of these parts can be developed independently and efficiently. So using that model, these three files actually reflect or represent each of these components of the model. My main activity file represents the controller part of the design pattern. So the controller, like I said, is the entry point, and it contains the class, the application class. So within the controller, we have a Kotlin class named main activity. So within the main activity class, we have our functions and our state variables. So the functions are actually used to, communicate or coordinate all the processes of the application, and our state variable are used to store changes or states of our application. So so we'll come back to this. Let me quickly explain the view. So main screen file represents the view of the application. The view practically means the graphical user interface, the theme we use, the layout of our components, our graphical components, like our buttons, our text fields, our icons, and their settings. So we define them within this main screen class, and we made use of jet compose functions, which is the new way of defining UI for Android applications. The previous one, or the old one, was XML, but it was slow and also buggy. So within our main screen, we have composable function. These functions actually represent, when they run, they actually create or emit the graphical objects that our user interacts with while using the application. So as you can see, and we also define some state variables. These state variables are actually used to track the states of most of these components. For instance, when a button is clicked, an event is being generated. And when an event is generated, so there's a state that is being changed when an event is generated. So this state has to be tracked. This state has to be controlled so that the application is not going to break. So that the application is going to work smoothly. So that is why we created some state variables, and also, have a way of tracking them. We made the states, of course, mutable. So so our view, we have composable functions, like I said, and these composable functions we have are like the main screen, which is the container, the super container that contains other sub components of our UI. Like we have the column. This column is like a setting. The column is like the setting of the main the whole the screen. So it defines the layout, how we want our graphical user interface components to be arranged on the screen. So we have our text fields, and buttons, and within these composable functions, we have some state variables that definitely change, and when they change, the application is going to respond appropriately because they are composable. So that's just a little background about the view. Then we have our model. The model represents our database, the data stored, and the structure of the data we have on our database. So here we have a text. Our database has text and an ID, which also reflects the data structure of Firestorm database we are using for our application. So we use the ID to track, like a reference to track our document object. And within the document, we have fields where data are stored. So this is just a breakdown of the MVC, model that I applied in building the application. So for this application to run smoothly with the back end, I imported some dependencies, and they are being stored in this Gradle script. This Gradle script is a dependency or package management tool of Android Studio. So it's used to manage files and other programs that the application needs, even within and also outside the Android Studio framework. So here I imported for the build Gradle project part of it. I imported this plugin. Then for the build Gradle module, the application part of it, I imported these ones here, as you can see on my screen. They are being highlighted. They have these yellow underlines. So after importing, I synchronized it with the default dependencies, the default packages, so that it's going to work smoothly. So this is just a preamble of the technical aspect of the application. So let's move on to the demo so that you see how the application works. So while I'm doing the demo, I would like you to take a look at the log card section, because this is where the logs of the application, the processes, happening behind the scene. This is where they are being visualized. So for the first part, I will type in my name, Chimezie. Then I also type in my last name, first and last name, and I'll type in my preferred name. So now I'm going to click on this button, this get a new random question. As you can see, there's an output message here. This shows that a question is being fetched from our Firestore database. It means that the communication is successful. So what happened here is actually that the application sent a request to the Firestore database, and the Firestore database responded to the request, and retrieved the questions I have on my database. And these questions are stored in one of the state variables which I showed earlier on. So they are stored as a list, a mutable list. They can be changed. Then one question was randomly picked and displayed on my screen, as you can see. So I'm going to respond to that. And this question is also being tracked. The question also, there's a variable that is used to track the this current question. So I'm going to respond to this. So I've typed in my response in the answer text field, and I'm going to click on submit button. Now, as you can see again, the response has been grouped together with my name and the question as an object, and sent to the Firestore database, and stored rather to the Firestore database. As you can see here, this is the object that consists of my first name, last name, the question, my response to the question, my preferred name, and an ID. A hash code was generated to keep track of the object, because this is an object. So in the database, we need this index to reference our object. It is used to track the object. So it's just for easy referencing. So let's go on to my Firestore database to check if what I've done actually worked. So okay, let me get the reference. The reference is GYM8. Okay, so here's my Firestore table, my Firestore database. So I'm going to check if my response was sent back to the database. So I'm going to use the ID of the document to track the object that was generated in my application when I hit the submit button. So in order to successfully do that, I'm going to refresh my Firestore database so that it's going to update its state. So this is GY. Okay, as you can see, this was the response I gave, and it's reflected successfully here. So thank you very much for watching.